Alrighty, should be live, I imagine. I can only guess. When exactly it goes live. So just a tiny bit of whatever this crap is, or just make a video, an intro video, and give myself the minute and a half needed to do this crap. Live, it says. That should be the live video. Do this, it looks like it is. So accomplish that task, and I just have to pop the chat out, and then I guess everything will be okay. So I did learn from the last adventure that even if Firefox crashes, it's still recording. It's still streaming somehow. So that's interesting. Yeah, that's what it is, interesting. So we're going to do another Professor Dave video, and I guess we'll just keep doing this, see if we can get him to man up and respond to some of these arguments instead of being a hypocrite and pretending that his physics is above critique and everybody else's isn't. Yeah, so he's, he can take it, but he can't, he can dish it out, but he can't take it. That whole kitchen thing. I can't handle it when it's directed towards him. And his weak, feeble mysticism. And that's all these videos are, is a story of mysticism. It's just a bunch of fables, pretend. It's not reality. It's not explained accurately or correctly or honestly. That's the only reasonable sentence, is to say it's not even an honest description of reality, because it's just so bad. Alright, so with that context, we'll just start with him, and then as soon as he gets to something worth drawing, I'll draw it and explain how everything he's saying is crap.
Professor Dave, I want to tell you about kinetic and potential energy.
So this is the big bullshit subject, where they're not really talking about energy in any other sense than, the difference between, well, your boat. You have a boat, and it's sitting on the shore of the Mississippi River, and now you're going to talk about what your boat has. Okay, the fact is your boat doesn't have anything but, smells and such. And it's not until you put it in the river that it's going to do something. And it's going to do it because of what the river's doing, not because of what the boat's doing. And then all the other examples, outside of gravity, are kind of obvious examples of exchanges, relative exchanges. Two things could be flying through space the same way, but they make a relative change in each other. They have a difference in some other direction, and that difference, if they hit each other, will be shared. And they'll try to, in a sense, balance that difference. That's the process of collision. And that's the process. There's no potential thing. And the potential can only be in the sense of an object can be crushed, and it can be elastic and expand back again. So that, in a sense, pressure, if you apply pressure, you're basically applying heat. That's what it takes to pressurize a tank, is heat. And then what's happened is, once you have pressurized it, the heat is stored, and it's not hot anymore. It's a cold kind of heat because it's pressure, because it's like the compressed spring. It has plenty of capacity to spring back. The pressure's there, and when it does that, well, obviously then it's going to be cold. It's going to absorb energy anyway. So, yeah, well, that's close enough to on the subject. So let's play a little more.
He knows a lot about the science stuff. Professor Dave explains.
Fart.
We now understand a more rigorous scientific definition of the word energy.
So he doesn't have any scientific, rigorous definition of the word energy. It's to say it's 1/2 mv squared when that can never be transferred. So just understand, a rocket ship, big exhaust. Calculate the kinetic energy, useless number. because the rocket ship's only going to move with the momentum of the exhaust. It's the momentum that will create the equal and opposite reaction, not the kinetic energy. So it doesn't do you any good to calculate the 256,000 joules of kinetic energy when it only has 250 joules of momentum. And it's the momentum that's the only thing the rocket's going to get, the spacecraft. So it's just such a lie. It's just so stupid to make this argument that you have some understanding of energy when you're claiming the existence of a substance that never works, never does any work. And then you claim it does work when it never does any work. You can never collect it, ever. I mean, ever.
As being the capacity to do work.
So it never can't do any work. There's no example. It can't collect it in a ballistic pendulum, so it can't do any work on the ballistic pendulum. It can't do any work in a water wheel. It can't do any work in a turbine in Niagara Falls. Spin it twice as fast, you're only going to get twice as much energy, so half the kinetic energy is missing. Collisions, it can't be collected in a collision. It can never do any work. It's just a ridiculous statement.
But as we said, there are a few different kinds of energy, so we must talk about all of these varieties.
So the other varieties don't mean anything. It's just when you convert energy or heat into pressure. Its expansion and contraction is the whole function of the universe. And the contraction pressurizes, the expansion depressurizes.
First, we will discuss kinetic energy and potential energy.
So it's just silly terminology implying that there's some energy that's moving or active, and then there's energy that's stored. Well, the argument is the stored energy probably has plenty of force exchanges in it, the nucleus of an atom. And it's just a matter of you ejecting an electron and then two protons see each other and expand. So it has the potential to expand. And that's all you're really saying. You've loaded the spring and you're just looking for a trigger.
Kinetic energy is the energy an object possesses by virtue of its motion.
So this is just baby talk because that's exactly what frickin' momentum is. There's no distinction. Momentum is the energy an object has because it's moving. If it's not moving, it doesn't have any energy. If it's moving, it has energy. So duh. Same exact thing. Momentum. Same definition. So what's the point? What's the point of calling it science and saying you're going to do something explicit and correct and technical when you have two terms that have exactly the same definition?
If we recall Newton's second law,
So again, that's not Newton's second law. So Newton clearly said twice the force, twice the motion. 3 times the force, 3 times the motion. He certainly never said per second per second. He didn't square something called an acceleration. It wasn't in anything he talked about. So it was F equals the force is the change in your momentum. That's what the force is. It's momentum. You're just giving the word, you're calling it force when it's in the form of this thing you can't see, but it's really just the same thing as saying it's just like a big object hitting you. A big wind hitting you is the same thing as an object hitting you with the same momentum. There's no distinction. The force is momentum. Absolute fact, because that's all it is. You're just exchanging momentum.
we know that the application of some net force will move an object with some mass at some constant acceleration.
Right, and the constant acceleration breaks the whole concept of net force. You're talking about, so you just said it, right? Net force. It's not a net force. If the acceleration is constant, then you're talking about something over a period of time, and you haven't finished the sentence. You have an acceleration for a specific amount of time. It's a time-dependent force you're applying, so obviously you can't square anything. And they square the acceleration. That's the catch. That A is the whole, that's the little smoke and mirrors bullshit they throw in. So they should be just F equals mv. That's Newton's formula. If you want it as a ratio over time, then you just put it over time. So, but it's just the change in your momentum, change in your mv, not ma, mv. That's the net part. You have a net velocity after the force has affected you. It's that net velocity that is the change in your momentum, not the net acceleration.
We also know that work is equal to force times distance.
So we don't know that, and it's also just more of their mystical, fake, phony, fraud garbage. So it isn't force times distance, and that can be proven by rolling something on a surface, or it can be proven by just releasing a spring in space or something. The half mass will go twice the velocity. It's not going to go any more than that. And in going twice the velocity in space, it'll only travel twice the distance in the same amount of time. So force times distance is not applicable.
So if we account for the distance traveled by this object, we get that W equals FD equals MAD, or simply W equals MAD.
So none of that's true. So it's just stupid. So what else can I say? It's wrong and it doesn't work. Fact.
We also know of this kinematic equation for an object experiencing constant acceleration.
So, and again, nothing experiences constant acceleration in our real world except something following gravity. So again, they keep applying formulas to circumstances that have no applicability. There's just no way to apply this thing called a constant force.
If we solve for AD, we get this expression, which can be plugged into the above equation for work. After some simplification, we arrive here, thus deriving the work energy.
So they're just saying work before, work after. And I mean, momentum before and momentum after is you could just take off the square and get rid of the half, and then you have the right formula. Of course, it's just the net work is the net change in the momentum. And they just screwed it up for no good reason. And so this kinetic energy formula will never work in any circumstance where you're converting energy from the force into an object or from an object of different masses. It'll never work. Bowling ball versus bowling pin. Only thing that's going to be transferred is the momentum. Kinetic energy is irrelevant.
Theorem. This term, 1/2 mass times velocity squared, represents the kinetic energy of a system.
So, and it doesn't represent anything that you can ever collect. So nothing can collect it. There's no experiment showing it being collected. Every experiment shows it not showing up, it disappearing. And they never, like I said, there's no ballistic pendulum experiment. So you put a bullet into the big object, the masses combine, you conserve all of the momentum, and their theory is that 99% of the energy is still inside the clay or the gel or whatever you collected the bullet with. Yet they never stick a thermometer in there and prove it. Because it isn't there. It's a simple answer. It didn't happen. 99% of the energy isn't somewhere else. You did conserve the momentum. You did transfer what the bullet had in any form of energy. You did collect its energy.
So now we can express the work energy theorem by saying that when an external force does work on a system, the amount of work will be equal to the change in kinetic energy of the system.
So it just isn't true. So the change in kinetic energy of the system, most of the kinetic energy in any interaction will just disappear. Or you'll claim there's more of momentum than there is. You either create free momentum or destroy momentum. You can't conserve both of these quantities. So in no experiment do you actually conserve the kinetic energy, because in all experiments we already know you have to conserve the momentum.
If W is positive, the system increases its kinetic energy, and the change will be equal to the work done on the system. If W is negative, the system decreases its kinetic energy, and this change will represent the work that is done by the system.
So again, that's just silly talk. because we know in every example, we know which object is doing the moving from our perspective and has the energy. So there's no whatever unenergy.
Note the presence of mass in the kinetic energy expression. This means that if two objects with different masses are moving at the same velocity, the more massive object will necessarily have more kinetic energy.
So again, it doesn't work out that way in the sense that the only energy they have is their momentum, and so all that exists is the mv part. So if you actually collect it, it's not going to be there. But obviously the heavy object moving at the same speed has more momentum also. It's just, their made up kinetic energy doesn't mean anything.
Now let's discuss potential energy, which is forever intertwined with kinetic energy.
Whatever that even means. How so? So again, the only potential is elasticity. So the argument is that atoms are elastic, different things are elastic, and you can pressurize them and store in them velocity. So pressure is potential velocity, but that's the better way to state it. The only thing you can store as potential is potential velocity.
Potential energy is the energy an object possesses by virtue of its position in a field.
So that again doesn't say much. So he's saying electromagnetic. Well, that's basically just saying the atom has electrons and protons in it, and you can compress two electrons and create a potential for the electrons to expand. That's it.
Whether that is a gravitational field, an electromagnetic field, or any other type of field.
So the gravitational field is the simplest one because it's obviously just comparable to rain or water or wind. It's a force that actually is like the Mississippi River, and all you have to do is untie your boat and your boat will move in the river. It's that simple. The river has the energy, not the boat.
If you lift a ball up into the air, you are increasing its gravitational potential energy.
So it has no gravitational potential energy, and all you're doing is saying it depends on how long you're going to allow it to fall. So all you're saying is the lifting part doesn't matter. I could lift it on a 100-foot podium 10 feet, or I could lift it off the ground 10 feet. The 10 feet that it's going to be allowed to fall is the only part that matters. It doesn't matter that it's 100 extra feet in the air. So again, it's just it's implying that the ball has some sort of property it doesn't have. It's just a ball waiting to be pushed by a force. It's a boat waiting to be pushed by a current. The boat doesn't have any energy. It has to wait for the flowing river to give it motion, to share its motion with it. It will take the energy from the river
as it moves farther away from the ground. If you release the ball, that potential energy is converted into the kinetic energy of motion as it falls.
So nothing's converted. You're just taking energy from the river. The boat, if I put a boat in the Mississippi River, the fact is the Mississippi River is a little less powerful because it gave energy to that mass.
The closer an object is to the center of gravity of the Earth, the less potential energy it has.
So again, we know that that is an extreme kind of thing. You can go miles and it will be, for all practical purposes, exactly the same amount of gravity per second. So to get out of 9.8, you have to go thousands of meters to get to 9.9 going that way, and 9.7 going the other way.
And as you pull it up and away from the ground, it gains potential energy because it has an increasing potential to fall some distance.
Now, so it has a potential to fall time. So we know, look, it's a time-dependent force. I don't even know how, would he actually utter the words that 9.8 meters per 1 second isn't a time-dependent force? It's not a distant-dependent force. It doesn't say 9.8 8 meters per second per foot. It says per second. It's not per foot or per inch or per centimeter. So again, just nonsense.
To the ground. It may seem strange to bestow an object with more energy just by lifting it into the air.
Right, you didn't just bestow it with anything. So just again, the argument is it has zero energy till you cut the rope on the boat, until you allow the exchange to take place, and it's clearly just an exchange. The force will be hitting the object and apply its motion to it. It will give it force. It's giving it something it doesn't have. So the potential is all in the force. It's not in the object you're releasing in the force. It's just so wrong to describe it any other way. All right. So, no chatters yet. Oh, only 4 viewers. Not too good. All right, we'll play some more and then draw.
But remember that we have to eliminate our prior conceptions of the word energy.
So again, this prior conception part just doesn't mean anything. We know energy is motion. You just described the definition of it. So it's mass moving. And that's exactly what momentum is, mass moving. So it's just silly to say we need some other notion. And the only argument is which one is real and which one is fake. Both of them can't be conserved unless you have a Newton's cradle thing where you claim there's kinetic energy, where you just make it up, and then you're putting it in the same mass object. But anytime there's an exchange between unequal masses or particles of different sizes, you won't conserve the kinetic energy. And that's just the absolute fact, and that's the giveaway that momentum is the only real thing.
In favor of more rigorous definitions. The potential energy of a compressed spring or an arrow ready to be released from a bow is where the kinetic energy of motion comes from.
So, and again, what does that even mean? And we know that the arrow doesn't have any energy, and we know the spring, whatever you put in front of it, doesn't have any energy until you release the spring. The spring has the energy. So why are we talking about the potential energy of the object when it's the potential energy of the spring? Jeez, mouse. Yes, there.
It is like a kind of stored energy.
There you go. And you could say the stored energy has to be in the form of pressure. You have to use pressure to compress the spring. You have to use pressure to expand the bow. You have to use pressure to store energy.
In this course, we will frequently be discussing gravitational potential energy for objects on Earth.
All right, so PE, which doesn't mean anything. Again, this is potential energy. It just means what's the river doing. And they say it's mgh when it's obviously mgt. It's the amount of time you're in the force that'll decide how much energy you'll collect. And that's it. How long is the boat in the river? That's all that's going to matter. And so say if I was to push a boat across a river, all that's going to matter is how long was it in the river. Will decide how much off from the straight line it is. So the faster I push the boat, the less time the river has to push on the object, and the less it's pushed, obviously. I mean, it's just so obvious. It's a time-dependent equation. It's not the distance from the shore to the other shore that matters. It's not the distance that makes any difference. It's the time that makes all the difference. And so I guess I might as well draw here. Might as well. It's been over so many times that, it's just the simplest gravity argument is just to say you have an object that's going to go past. Oh, could have put that. I could have done that. Well, look, we'll just make this the big object. So this object is going to move, through a gravitational field. And what matters? How far this distance is. This 0 distance, we'll call it, and this is 100, and we'll just have this arbitrary distinction for a distance. And then we'll say, it's always the same amount of energy. And it's not. Clearly, what's going to matter? Well, if it goes really fast, then it barely gets turned off course. And if it goes really slow, it doesn't ever even get across the distance. It crashes here. So it's obviously, it's about the time you're in the force. The force is a stream of energy, and you collect the stream based out on how long you're in the stream. Done. Finished. Obvious. Complete. It's an undebunkable argument that time is what matters, not distance. Distance is irrelevant. All right, so then let's go to the classic example. And again, this goes back to the fact that physics is asserting a truth, and it's never proven the truth. So it's asserting that a one mass dropped 4 units of distance, okay, but only 2 units of time. So it's 2 time and 4 distance, okay. And their claim is that one object going just those 2 units of time somehow collects 4 units of its energy, based on its mass. And then you have a 4 mass, okay, and it only goes 1 unit of distance. And their argument is that those 2 things are the same, even though you can do the obvious calculation and say 2 units of force here, 1 unit of force here. This is 1 second, so to speak, and this is 2 seconds. Okay, so it's only 2 units of force. This got twice as much force, twice as much time in the river. And this got 1 unit of time in the river. But the mass is 4 to 1. So obviously this still has more momentum. This has 2x, the momentum, okay, the mv, that this has. On its face, obvious. And why does that exist? Well, because when you were given the 9.8 here, and this has the 9.8, okay, velocity, well, that means you get this whole distance for free. You're not collecting anything. This is free motion. And the second unit of motion is this, 4.9 meters here in 1 second. That's the only thing added. And so you added 9.8, and so this lands with 19.6, and you're done, in the sense that this is just going twice as fast, but it's only a 1 mass, so it's only 1/4 of the mass going twice the speed, so it has to be half the energy. But they never done an experiment. And again, the simple fact is how do you undo the fact that it's 9.8, you could say, meters per second, okay, over 1 second. If I change this 1 to some other number, I have to change the 9.8. It's just obvious. You can't break that ratio and say this is somehow second squared. It's not 9.8 meters per second squared. It's just 9.8 meters per 1 second. That's the end of the equation. That's the end of Newton's statement. There's no per second, and there's no notion that to quantify in a formula per second, it means you say second squared, because it's not seconds per squared. Per second means it's the seconds times how many seconds it took. It's not squaring the seconds. Just isn't. So it is just terrible physics. Awful, horrible, nonsensical garbage. All right. There's dark endless. I'm sorry you don't have something better to do every night, but oakley doke. So on to the next bit.
And for any object, this will be equal to the mass of the object in kilograms times the free fall acceleration due to gravity for the Earth times the height.
So again, it's just the gravitational constant is in 1 second units. So it's 9.8, and so where are you multiplying by the time? You're not multiplying the g times any time. It's 9.8 per 1 second. You have to multiply it times some unit of seconds. Where's your unit of seconds to multiply it by? The mass isn't seconds. You don't have seconds in your G. Okay, you just have the 1 second that you're assuming per 1 second. So you don't have a complete statement there. So where's the number of seconds in the formula? Obviously it's missing because you put a silly H there instead of a T.
Height of the object in meters. The greater the height, the greater the potential energy.
So again, it's not about the height, it's about the distance you're going to allow it to fall. And the distance you're going to allow it to fall is going to mean a certain amount of time it will take to do that falling. But the time is all that matters. If I slow it down, if I slowly drop something, I will have to absorb more force than if I allow it to fall quickly. So if something's falling slowly in gravity because I put tension on it, it means it is in gravity longer, and whatever rope or string or anything I tied that weight to, it will endure more force because it's going to be in the force a longer period of time.
This represents the work that can be done by gravity.
So we know this won't work in any circumstance where something already has motion and it comes into the Earth's range. So this formula will do you no good if something already has motion. So if something's already going 50 miles an hour towards the Earth, you can't use this formula. I mean, that's how limited it is, and that's how it's just a trick. It's just smoke and mirrors bullshit. It's not about the height, it's about the time.
To produce the motion of a falling object. There is also elastic potential energy, such as with the spring or the bow and arrow. And we will discuss this later as well.
Yeah, where? Yeah, I haven't found that video yet.
For now, we just need to understand kinetic energy as the energy of motion, and potential.
So we know that momentum is the energy of motion also. So there's no way to getting around it. MV is in both equations. And the question is there any reason whatsoever to think there's such a thing as a squared velocity? And the obvious answer is, of course not. You can't square a velocity. You can't have a cube of velocity. Not possible. It's a linear amount of something. It can't be volumized.
Energy as the energy of location. Let's check comprehension.
Oh, this was a terrible feature you started adding. Oh. So whatever this is, an object of mass 50 kilograms moves at a velocity of blah, 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 blah. So obviously it's just, the right answer is just multiply by the time, and you'll get the right answer. So none of these joules numbers are ever measured, so they have no experiment proving or demonstrating. It's just a statement they're making. Again, they're saying a one mass going twice the velocity has the same power as a 4 mass going 1 velocity. It's silly on its face. 100-pound guy going 1 velocity, 25-pound guy going 2 velocity. Which one do you want to get hit by? They say it's the same. Okay, it just can't be. So whatever this is, just a waste of time. Just waste my time. Thank you very much. Alright, so I guess we have to just skip this kind of crap. They love to do their little silly nothing problems. Okay, I don't know. Yeah, just a bunch of bullshit. So whatever. 20% of the video is this crap. Yuck. Alright, so we'll move on to another video. Such, as there is no chatting. Yeah, only 4 viewers, very bad. Can't do any business this way. Alright, so maybe we'll go to the playlist, and then we can see these in the right order. Yeah, that might be more fun. Alright, so I'll go to the playlist. Yeah, they load the video.
With Liberty Mutual, you can customize car insurance.
It's even more annoying. All right, so introduction, and then you got scalars, vectors, and vector operations. Well, we know that vectors make sense, but scalars are silly. So we have position, velocity, and acceleration, which, gee, does that really make any sense? And it's a part 1, which is really silly. So, yeah, I don't know if that's worth the wasting time on. Well, since it's there, we'll do it. Okay, what the hell. You know, we have to wait through the commercial, so I'll try to turn the sound off.
Hey, it's Professor Dave. Let's discuss position,
Okay.
velocity, and acceleration.
Yeah, so we'll just... obviously this is all just mush, okay? The acceleration is just a change in your velocity. You add velocity. So, and to call it some other thing when you're just adding the same quantity you already have. So you have 10 miles an hour and you're just going to add another 10 miles an hour to your condition. There's no point in calling that something special. It's just added velocity. Acceleration is just adding or subtracting velocity. It's not some other substance. Alright, so pop this out. And that should work. Let's see if it's there. Yeah, it's there. Alright, so let's play some of this crap.
He knows a lot about the science stuff. Professor Dave explains.
Part.
In physics, we will often be asking questions like,
Alright, so right there is the whole show should be Rover. So as soon as one of these idiots starts talking about energy, kinetic energy specifically, and shows a rocket ship, the conversation should just stop and the Monty Python guy should come out and say, too silly. Okay, your sketch is too silly. Your argument is too silly. This is nonsense. Rubbish. This isn't physics. It's too silly. Because it's just too silly. The kinetic energy of that flame will not be what the rocket gets as energy. So obviously you won't be able to convert any of the kinetic energy into motion. Zero. None of the kinetic energy portion. The only part you'll be able to transfer is the momentum. All the kinetic energy will do no work anywhere in the universe. Because it can't do anyway, because it doesn't exist. It's a fable.
where is an object? Which way is it moving? And how fast? To discuss the answers to these...
Well, that's just too silly a pose of a question, isn't it? We know we can't do any of that absolutely. So I can't know my absolute position or my absolute velocity, and accelerations are just, not relevant, frankly. It's just my velocities that matter.
questions, we will frequently utilize the concepts of position, velocity, and acceleration. So before we go any further, let's define these terms. Position is simple. It's just where an object is in space.
All right, so again, it's not simple because we can't know it. So all we can know is relative positions and conditions. And the only part of that that really means anything is conditions. Will things hit each other? That's all that's going to matter. Are they going to interact? And then what's going to happen when they interact?
Usually this is discussed with some kind of reference point or axes in mind. And we might express the position of an object as being some distance from this reference point in meters.
Right, so this again presupposes their axiom that somehow distance tells you the truth when distance doesn't tell you the truth. It's just a fact that the object dropping 4 units of distance in gravity is only dropping 2 units of time in gravity. It's only in the stream 2 units of time. The distance is irrelevant.
Velocity is the change in position over time. So if this object travels 5 meters in 5 seconds, it is traveling at a velocity of 1 meter per second. And acceleration is the change in velocity over time. So if this object starts at a standstill and over 5 seconds gradually speeds up to 5...
So we know that in the case of the object rolling, that it somehow isn't changing, it isn't decelerating consistently because it goes half its speed 3/4 of the way down the track. And it doesn't matter which object I'm rolling, right? I can roll something at one velocity. It's doing the same thing. It's going half its speed. That is, it's going 0.5 velocity 3/4 of the way through the trip, because gravity is creating your friction, and that's the consequence of a constant force applied. Is that the fact is, in units of distance, it will change how much force there is. So you're not going to get the same amount per inch of acceleration in your free fall. So you get a lot of acceleration in the first 4.8 meters or the first second. All right. But in the second one, you're not accelerating. You're only going to accelerate a tiny amount per a giant amount of distance because you already have a velocity. And you're going through that second. You're going through a lot of distance in that 1 second. And you're only going to get 4.9 meters of extra distance, and you're only going to get 9.8 meters of extra velocity, added velocity. And those are the facts. So again, all this distance crap doesn't have anything to do with calculating energy. Energy is about time. It's about how much time you're interacting with something, whether it's a stream or bullets or a weight. If the weight travels over my head, let's say there's a car. I dig a hole in the road, and so I can sit inside the hole, and just the top of my head sticks out of the road. Okay, the fact is, if a car parks on it, I'm dead. But if cars roll over it quickly, I'll barely feel it. So it's about how much time is the pressure being applied. Yeah, duh. And how much pressure is being applied. Now, obviously, the faster the car moves, the less time it's over my head. That means the less time the weight has to apply weight. The car simply doesn't have enough time for its tonnage of weight to push on my head. It's all about time.
Meters per second, then it is accelerating at 1 meter per second per second.
So there it is, the magic terminology. You're going 60 miles an hour per hour. Do I need to tell you that it's per hour? It wasn't already in the 60 miles an hour. I haven't already explained it's 60 miles per 1 hour. That's the rate. Why do I need to say per hour per hour? I don't, obviously. And you obviously don't need to say per second per second. It's silly, and it just gives them an excuse to create a squared acceleration term. And it's not a squared term.
Or 1 meter per second squared.
Right. The squared it doesn't belong there. It's 1 second. It's 1 meter per 1 second. It's not second squared. It's just not true. It's not accurate. It's not science. It's nonsense. Non-science.
So that's how we define position, velocity, and acceleration. Now let's discuss each of these in more depth.
Oh, please don't.
When we talk about position, we could discuss distance or we could discuss displacement.
So one of them, they're pretending that somehow if you go up and then you go down, and then you go up and then you go down, the total displacement is this, but the total distance you actually traveled was huge. So obviously I would argue that, yes, if you're a basketball, being bounced on the court versus the player. So the player has a displacement. He moves 10 feet, but and he only travels 10 feet per 1 second or something. But the ball will obviously travel a lot more than 10 feet because it's traveling a very long up and down track.
The difference here is that distance is a scalar, while displacement is a vector.
So both are silly. It's just silly distinction. And what you're arguing is whether, it's like you're pushing on a balloon. Obviously the balloon will push back, so all the energy that you put in, you'll get back again. So you did zero work in the sense that technically you could collect back the energy you used to push in. You could just collect it back if you can collect it in the opposite direction. So it's just pressure, and then the pressure pushes you back, and then you push the pressure, and the pressure pushes you back, so there's nothing used up, so to speak.
Let's say you and your friend get dropped off by the school bus at this intersection, and your house is here. Your friend begins to walk down the street and up the driveway, like a normal person. But you find yourself so overcome with excitement to play video games that you decide to plow through the yard in a straight line to the door. Your friend has to walk 20 meters down the street and 7 meters up the driveway for a total of 27 meters. So, using the Pythagorean theorem, we find that you only had to walk about 21.2 meters, and you probably got there a little sooner.
Yeah, well, you probably got there sooner. Why did you just say absolutely if you're traveling, presumably walking at the same speed? Then obviously 27 is going to take longer than 21. So why even play that game? But again, all of this doesn't mean anything. This doesn't have anything to do with energy.
What we can say is that you walked different distances, which are represented by these scalar values, but you both had the same displacement because you ended up in the same spot at the front door. This vector, which follows
so again,
the straight
what's
line
the
path,
point of
is
saying
the displacement.
Anything other than obviously the shorter path is a shorter path. You'll do less work, so there's no point in even talking about it. It's obviously more work to go 20 meters, 27 meters than it is to go 21 meters. So why is it a conversation? Now, if you're going uphill, yeah, let's see. It's still a shorter distance, so it'll take you less time. So you'll fight gravity for less time. So you're still going to have the advantage of taking the shortcut.
Vector for both of you. And we can report your position with x and y coordinates like this, 20, 7. Or we could report the magnitude of the displacement vector, which will be equal to the shorter distance you traveled, and calculate the angle off the horizontal using trig functions if we desire.
So none of this makes any difference to the simple point that one path is 27 meters long and one path is 21.2 meters long. So what's to argue? Oh, that's right, nothing.
In order to report the direction of the vector. Next, let's look at velocity, which is the rate of change in position.
So again, rate of change of position, and you're just saying it's not necessarily a rate, right? I mean, you're going a constant velocity. You're going to have to say it in units of something. So it has to be feet or something, and then a unit of time. So you can't evade that part of it. But you don't have to think of it as distance. You can just think of it as, well, it has to be thought of as distance.
People assume that the words speed and velocity are synonyms.
Oh, whatever. So this is the silly part, that somehow that there's ever a difference between a speed and a velocity. There's no such thing as any difference. You can't have a speed and a velocity and have different numbers. It's not possible.
And in everyday language, they are. But the difference in physics is that speed is a scalar.
So it doesn't mean anything, though, because you can't state it in any other terms than exactly the same terms you're going to state a velocity. So your scalar word doesn't mean anything. 60 miles an hour is a scalar. 60 miles an hour is a vector. It's 60 miles an hour. It's over. There's no scalar part.
And velocity is a vector. If a group of kids are playing hide and seek and they all run away from the seeker in different directions.
Well, that's not the example. We're talking about one person running away from another person. Okay, now you're going to combine and say what's the net movement of the entire object. What does that have to do with anything? That doesn't have anything to do with their individual velocities and the fact that they're not scalar velocities. So again, it's just bullshit. You're not, nothing in the, there's no real world example where this would mean anything, where this would be useful information.
It is possible that they all run at the same speed, because speed only has magnitude and no direction.
So again, isn't that just silly? Everything that you just showed them moving in a direction, and the argument would be, I would argue, that real physics is particle physics, and there's no way you can undo that. And so everything does move in vectors. So nothing ever waves. Even water in the ocean is a bunch of individual atoms. It's not waves. It's individual things moving individual directions. So I don't think you can come up with an example where you can demonstrate anything having no direction.
So they could all run at a speed of 3 meters per second if they are quick little devils. But each kid would have a unique velocity vector that has a magnitude of 3, but also describes the direction of motion.
So again, it doesn't make any sense. So, and what would be the scalar value?
Most likely using the seeker standing still as the point of origin. Velocity vectors will be extremely important as we move.
So we know that that's all there are. So again, where's the scalar vector? I mean, the scalar chart. Draw me the chart with scalar energy on it. Show me the scalar energy.
Forward with kinematics, where we will study the motion of objects. In general, average speed can be calculated by taking the distance traveled by an object and dividing by the time.
And that's all we can ever know is some sort of average speed, right? Because we can't, see the tiny bits moving their actual speed. And then we know in some circumstances the average speed is a distortion, like in the case of the ball rolling, because the fact is that it's going to move half its velocity 3/4 down the track.
It took to do so. So if you walk 85 meters in 46 seconds, you are walking at an average speed of 1.85 meters per second. To find average velocity, you can do the same, but you would have to divide displacement by time. Lastly, we have...
So again, it just won't give you the right answer, though. You're going to be deceived if you're saying, well, the average speed is 1/2 of 2 units of time. And, well, that's not going to be correct, though, if the object was under different amounts of friction and losing energy at a different rate. So the average speed is actually higher because most of the trip it was going a higher velocity, and it wasn't until the last part of the trip that it lost most of its energy. So because you're losing energy disproportionately, you're not going to get a right answer. Your average isn't going to be your actual time-dependent average. All right, let's see. What is life, guys, here again? Surprising they haven't done some of these basic experiments testing KE versus MV. I don't even know what to say on this subject just because these are really simple experiments, right? I mean, I've detailed it before. You think they would just be curious. Gravity's pushing you into the ground at a rate. It can be measured on a scale, and the spring compresses, right? And again, all they have to do is turn the scale sideways, then put an elephant and a mouse on a pendulum or whatever, bring them in at a certain velocity, and see how much they weigh. And there's a velocity where the elephant will weigh elephant, and the mouse will weigh mouse. Now, why wouldn't science do that experiment? I mean, it's a very interesting number that would be. I claim it's 1 mile an hour, which is kind of coincidental. It turns out to be pretty close to a whole number like that. But regardless, that's the interesting part, that you're moving into the ground at 1 mile an hour. That's the practical effect of your weight, is you having the momentum of moving 1 mile an hour. When you're moving 1 mile an hour, you will weigh your gravitational weight. You will apply a pressure to whatever you hit that will be equal to your gravitational weight. That's science. I mean, that's something a scientist should want to know. Amazing. Never done it. Let's see. Does Dave do any experiments? Of course not. I mean, people aren't obligated to do experiments, okay? Some of them are technical. They have to be done well. They should be done by technicians, people who understand machining and lubrication and friction and all of that stuff, because the experiments have lots of defects if you don't do them well. You can see videos on YouTube where people drive at different speeds over large potholes. The faster the car goes, the more the car is unaffected by the pothole. Yeah, obviously. But I'm just saying yes, it's not only obvious when you physically think about it, but I'm just saying it's obvious in the physics itself that it has to be true. You can't miss it. It's the simple gravitational argument of, you have a gravitational body and you move through the gravity quickly, you're less affected by the gravity. So again, it's just so obvious that, yes, the faster you're going, the less friction there is. Less friction there is, the less you can transfer your energy. And obviously, in the case of a pothole, you can't fall into the pothole very far unless you have time to fall. And if you don't have any time to fall into the pothole, well, then you're going to have less of a disruption in your forward motion, because you're going to be doing less going down and getting pushed back up. Duh, so to speak. But yes, it all just demonstrates that this force is dependent on time, not on distance.
Have acceleration, which is the rate of change in velocity. This is always a vector because acceleration must occur in a particular direction.
So even that doesn't even. How do you know that this vector? Why can't you have vector acceleration? If you can have vector velocity, speed, why can't you have vector acceleration? It just doesn't make any sense. I mean, scalar.
If you are in a car that is standing still and you press on the gas, the car will begin to move forward with a fixed acceleration.
So there's no fixed acceleration. So that's the catch. As the car moves, you have to apply more gas if you want to have a constant acceleration. And you would have to apply just the right amount of extra pressure. So the pressure is releasing as the car moves, obviously. The engine would be doing less work as the car is moving, and you have to apply more gas, perfectly consistent with how fast the car moves. So that would be pretty much impossible. So there's no constant force in this case. You can't apply a constant force because you're not sensitive enough. You're not a delicate enough instrument to be able to detect velocities and compensate for the motion already acquired.
It might accelerate slowly, so the vector may be on the shorter side, but this constant acceleration will cause the velocity to increase at a fixed rate.
So none of that can happen, actually. I mean, you just can't do it. I don't even know if a computer could do it perfectly. So again, it's just it's a bad example. Frankly, it's not a very good example of what he's trying to demonstrate. He should just use gravity, because constant forces are almost impossible. You need to know exactly how much friction there is. You need to know, there's just no way you could do that calculation to adjust the force you're applying based on how much energy you're losing to friction and how much the car is actually moving.
Let's say an additional meter per second every second. So over 5 seconds, it will reach a velocity of 5 meters per second. Let's say you see a skunk in the middle of the road. It's your most favorite animal, so you slam on the brakes. We can describe this as a deceleration, which is an acceleration in the...
So we know this is just energy transfers. You're just going to sit there and first gain momentum from the motion of the engine, and then you're going to lose momentum to heating the brakes or, leaving rubber on the road. So we know it's just exchanges of momentum. And it's always Newtonian. There's no such thing as kinetic energy involved in those transfers. You're not going to transfer kinetic energy. You're just going to transfer momentum. If your kinetic energy of a car is 400 joules and you slam on the brakes, well, the only heat and the only friction and the only anything you're going to create or transfer is going to be what's your momentum. If your momentum's 40, that's all that's going into the ground. Is 40. The kinetic energy will never be realized as doing any work, as friction or heat or as motion, period. It won't transfer. Let's see, was later proven false. What are you talking about? Something was later proven false. What the hell are you talking about? It's sort of funny. The guy who has spent his entire life, let's see, combating conspiracies. What does that even mean? Loves to peddle conspiracies. What the hell does any of that even mean? I have no idea. So what conspiracy am I peddling? So you think religion is a conspiracy? It's not just people being stupid. So if I say science is a religion, you can't figure it out? Well, where's your first comment, jackass? Your first comment is, was later proven false. That's your first comment. Yeah, well, you're not talking about them very constructively, all right? So instead of being obscure, why don't you just say something direct and clear? And again, you're saying you have some first statement here. Was later proven false. What the hell is that? You don't see how that would create a continuity problem for me? I read somebody and they just say, was later proven false. What are you talking about? What was later proven false? You don't get it? Yeah, okay, you don't get it. Please be more clear in your statements. Don't be obtuse. Be direct. Well, it's still delayed, okay? So it's like kinetic energy. You can't collect your comment. It's a KE comment. It's uncollectible.
Negative direction. Since you are going from a moderate speed to a...
Let me put, it says top chat. Sorry, let me do the... Why should I have to fix this? You have to fix everything. You have to go newest first. You have to do... Yes, I want the live chat. Thank you. Yes, give me the actual chat. Thank you. All right. Oh, yeah, there's stuff I didn't even see in here. Okay, let's see. All right, so let's see if I can find your comment, original comment. No, it still isn't there, buddy. Oh, here it is. I've never taken him serious after his whole video on transgenderism, which was just completely nonsensical and retarded. Well, I don't know what talked about brain chemistry and some other study from Ithaca University that was later proven false. Well, it is kind of a messy subject, don't you agree? I mean, there's obviously, just, you could argue that human beings, manifest behaviors that are completely inconsistent, right? And even things that are like, somebody could tell you, look, if you're 40 pounds overweight, if you just spend 2 weeks being uncomfortable, you can lose the weight and not have it for the rest of your life. So 2 frickin' weeks, not a big deal, and they can't do it, right? But they'll tell somebody else to quit smoking, or that kind of thing. So it's all this psychology that fucks with people. But I don't know what he could possibly say on the subject that would be... I don't know if there's anybody who says anything on that subject that you could say, yes, that's how it works. That's why, people with penises want to have vaginas. No point. I don't think there's any point in saying I can diagnose that. I know why that happened. No, you don't. I mean, every individual is fucked up for different reasons, I would argue. But anyway, see, that's not even a physics subject, so, it shouldn't even mess with that one. Don't talk to me about why Professor Dave is a bad biology professor. I want to talk about how he's a bad physics professor. But anyway, okay. I'd say you're pretty dumb and old. Well, that's just useless. So you're pretty lame and, limp-dicked. Yes, you have a very limp dick. Can't come up with a real argument. So we'll time you out for a half an hour. Okay. Useless mush. You are ugly. You have a micro penis. I'll just make a bunch of accusations at you. You smell like doo-doo. Alright. Alright, so the rest of it was already done. My comment must have been delayed, lol. Okay, me, whatever that is. NVM. I don't know what that means. Oh, shit, people. I asked him to be clear. He types NVM. What the hell does that mean? Oh, shit.
Standstill in a very short amount of time, this vector will be quite long and pointing back towards the origin. Now we understand distance.
So again, all you can do is exchange. So you're exchanging conditions. So every interaction is an exchange of conditions, and that's all that takes place. And it's almost silly to say one condition is a negative condition and one condition is a positive condition. No, they're just an exchange of conditions.
And displacement, speed and velocity, and acceleration. And we can categorize these as being either scalars or vectors.
Alright, so again, more of this scalar vector nonsense. What the hell is a scalar? Draw me some scalar. Show me how something scalars. Show me where the scalaring is of the 10-ton train going down the tracks. Show me where its scalar energy is.
Before we finish, let's look at a moving object like this marble rolling to a stop and visualize all three of these vectors as the object moves.
Alright, so you're probably going to get this wrong, right? So he's going to pretend that it's the same amount of friction regardless of its velocity. And that's just not true.
First, with displacement, this vector will just elongate as the marble rolls and will span the distance traveled. For velocity, the vector will point forward as
there, so he's got it wrong. So he's got it going half the speed at half the distance. It won't do that. So it's wrong.
the velocity is positive, since it is moving in the forward.
Obviously, this table is taking the energy, so we understand each other. This isn't a ball rolling in space or moving through space. It's a ball on a table. You're going to consume its energy. The fact is, it's an absolute fact, that it's going to consume its energy unevenly. It will not be going half the speed at half the distance. It will be going half the speed 3/4 of the way down the track. That's the absolute fact, and you know it because you know exactly what this experiment would look like if I gave it 1 unit of velocity. And that's what 1 unit of velocity will look like, is just that 1/4 of the distance. So it's just an absolute fact that it does not do what he just described. It does not consistently decelerate. It decelerates a lot more at the end than it does in the beginning.
Direction, and the vector will.
Have you confronted Professor Dave in his comment section? You know, that's the problem. Yes, I did confront him, and I did ask him, you know, please tell me how much I have to pay you to address my arguments. And he gave me some silly number like $10,000 or whatever it was, 100,000. It was some kind of like non-starter amount, and I just kept saying, you know, these are arguments that need to be addressed, and you're all just cowards, and, you know, blah, 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 blah. And he just dismissed my arguments as pseudoscience and flat earth, and I just said, I'm willing to pay you to debunk me, and he just won't do it. What video was it? Hell if I know. It was years ago. I have, over the years, like periodically, I have resent emails to him. So I even had a thing where every month I was having everybody send emails, and Dave is on the list. All right. So it's like I keep reminding him that there are arguments to be addressed, and I'm willing to pay you to address them, and none of you pussies will man up. So I don't want to have to do this in every video, but I offered Thunderfoot $4,000. I offered Veritasium $4,000 to play a 5-minute video, and they wouldn't take my money.
Move along with the marble, but it will decrease in magnitude as the marble slows down, until eventually disappearing when the marble comes to a rest.
So it's just wrong. So what he's drawing is wrong. There's not a consistent deceleration. The deceleration is much more extreme. The slower the object goes, the faster it goes slower. It's just that's the way it works. The faster it's going, the slower it slows down. The slower it's going, the faster it slows down.
Where it has 0 velocity. And then for acceleration, the vector points in the negative direction, since velocity is decreasing or becoming smaller.
So obviously it's a deceleration. I don't know why you would bother calling it an unacceleration or whatever you're doing, but it was just too silly. All right, whatever this is. Okay, he tends to be more hyperactive in the comment section nowadays ever since Flat Earth. There is no flat Earth. This isn't a real thing, okay? It's a tiny segment of human population that plays flat Earth. Why is he wasting time on it when there's 4 million other people debunking it already? And it's not even worthy of debunking because it's all made out of lies and deception and dishonesty. So why is that a physics subject? So kinetic energy isn't a physics subject, right? The source of gravity isn't a physics subject. Quantum mechanics isn't a physics subject. Flat fucking Earth is a physics subject? Let's see. Wait, Veritasium said rubbish too. Well, Veritasium never responded. I just, I emailed his corporation and offered them the money, and they did not respond.
Per unit time. But it will be constant in magnitude, since this is a constant deceleration due to friction from the...
So we know it's not constant, so that's right there. You're wrong, Dave. It's never constant. Friction created by gravity is not constant. Okay, any change in velocity changes the amount of energy you'll lose to the surface. Absolute fact.
Surface it's rolling on. We can view all 3 of these at once, just to drive things home.
Okay, and there's no driving anything home. It's wrong, it's inaccurate, it's false, it's fake, it's phony. You're doing bad science. It's just bad science. They shouldn't be teaching a kid the wrong answer. And it's obviously wrong answer. I'm just saying it's just obvious. I mean, I shouldn't have to explain. One velocity will look like this, the same mass going one velocity. Right? And so we know exactly what one velocity looks like. And so when you have the true velocity that's 4 times longer, well, it has to be going one velocity here at the end, because we will know exactly what one velocity looks like. So we know the whole other section of the 3 units of distance, obviously it had more than half the velocity through that period. It wasn't going half the speed at half the distance. The deceleration was not constant.
Make sure you understand the magnitude and direction of each of these vectors at each...
Right, and just make sure you understand what you're actually doing. You're pulling the energy out of the object by connecting it to the table through the pressure of gravity. Understand that it's not what something would do in space, and that this circumstance means that, yes, you have a very... there are no such things as a constant drain. The table is not capable of constantly pulling the same energy out of the object. As it slows the object down, it pulls more and more energy out of it.
Each moment in time. Let's check comprehension.
Let's not do that. So we'll just call that part always the end of the video. Because, yuck. Let's take a pop quiz. Oh, God. Yuck. Anyway, I've, whatever that is, rage-baited Professor Dave multiple times. He's probably autistic in real life, considering he can't figure out the difference between satire and reality. Well, obviously, I've had a little trouble with your commenting. So, yeah, you could call me names too. I don't think anybody should be using satire. I guess, I mean, why be indirect when you can just say you're fat? I mean, why bother saying, you're plump as pudding or some kind of bullshit? So, yeah, just get to the point. I mean, and I would expect a scientist, the more scientific you are, the more direct you want somebody to be. You don't want to have to try to figure out the joke you're telling or the metaphor. You want it in the form of as close an analogy as possible. Give me a really good analogy. So I have the analogy of Sisyphus pushing boulders. So Sisyphus is the force, the boulders are the electrons and protons, and that's the only game in town. The Sisyphuses fly the speed of light when they're not pushing a boulder, and then when they're pushing a boulder, they're stuck going some kind of 10 miles an hour thing. They're they're going tediously and unpleasantly slowly. But it's an analogy that works perfectly. So good analogies are good. And like I said, I don't know how much satire. I don't know if that has any value at all, frankly. All right, so I guess I will close that and see if I can find another video. Oh, kinetic energy. I thought that was the playlist. Oh, there it is, the playlist. Okay, I don't even know what that one was called. Position, acceleration. Yeah, let's not do the second version of that. Horizontal motion. Horizontal, and then he has vertical motion. What the hell how could this make any difference except in gravity? Yeah, that's just funny. Should we waste any time on horizontal motion? Well, I'll think about it. I'll just sit here and think about it. Yeah, that seems like a good thing to do. Yeah, maybe I'm done playing these stupid videos for tonight. They're just really bad, and it's just, like I said, it's just generic Wikipedia crap. It's he doesn't add any value, doesn't add any contextual explanation that makes it all make sense. So he didn't say anything about what the fuck a scalar could possibly be. How a train or a car has scalar energy. So I don't know. Professor Dave must be stopped. No, that's not what we want. What we want is Professor Dave to accept challenges to the bullshit he preaches. I don't need to stop anybody. I just need a fair capacity to show them to be wrong, stupid, dishonest, and cowardly. Yeah, just give me that chance. It'd be nice if you made a book. See, this is the whole thing. I mean, why? Do you really think if I tried to explain it versus drawing it, that it's going to be so much easier to understand? I mean, drawings just get in the way, right? Who the fuck needs that? And then you have this whole idea of video, where I can do this interactive and active drawing, which is even better than just the figure, right? Watching the figure evolve is so much value. So you're, how can people think that if I wrote this, it would be so much easier to understand? You've got to be kidding me, right? I mean, if I had to explain the rolling ball thing and I couldn't draw it, no, it's not going to be more understandable. So I don't really get what you think you're missing. I mean, there is writing on the website. So if there's a part that says there something like, whatever, the mistakes of physics. And there's a whole section of writing. Now, frankly, I think some of the writing's pretty good in terms of getting to the subjects. I have to fix the gravity one now just because now that we know we have annihilated drag as a concept. But Yeah, I don't think it. I don't think it works better than a video. I mean, frankly, I don't even see how it's even close. You know, it's just so much better to see somebody draw what they're talking about. Anyway, Professor Dave must be stopped, so no, I don't think so. A summary of all of your information in one book would be much easier to understand. Well, it says you, so I don't agree. I think the video I did the other night, you know, Professor Duff, the first one, 3 videos ago, where I talked about a ton of the subjects. I talked about gravity, I talked about charge, I talked about energy. I mean, all of them. I don't think you're going to sit there and say, oh, there's a... if I wrote an hour and a half of text for you to read, that somehow it would be more informative. There's just no chance. Let's see, these people, are they in the movement of scientism? Yeah, I read a whole book called Einstein. You know, it was this thick. And there was just, you know, the amount of useful physics in it was 1/1000th of the 1,000 pages. So like 3 pages out of the 1,000 pages were about physics. Robot, you're really dumb. Okay, I mean, this is just baby talk. Professor Dave isn't any worse than Veritasium or Steve Mould or any science presenter on YouTube. He's not even worse than Professor Lewin. They're all just shit talkers. They say things that just aren't true about experiments that never happened. You know, it's just all mush. Again, he's talking about, you know, motion and gravity, and he's never dropped 4 pounds 1 foot and 1 pound 4 feet. And proven that it's the same energy. He's never proven that a 25-pound man going twice the velocity is the same impact energy as a 100-pound man going 1 velocity. He's never done the experiment, never even thought about doing it. Well, I mean, look, you call yourself robot, and then you really just should be trollbot, right? I mean, not saying anything useful. Bad people kill. You know, is that a robot? No, that's a cow. That's an adding machine. You know, adding machines say stupid things like that. Or try to be a computer. You know, say something intelligent. Yeah, I'm supposed to give up nicotine this year. Yeah, I just don't know how I'm going to do it. Oh, God. I just like feel like I need to fill up a glass full of nicotine. What I need is a real cigarette. That's what I need. I haven't had a real cigarette in like 2 years. I miss them so. Anyway. But, you know, it's like everything else. You know, you smoke the cigarette and you say, oh, gee, I'm done smoking the cigarette, now I want to smoke another cigarette. You know, so you're just stuck. Can't win. Look at photos of rotten lungs. You know, why should that bother me? The cigarette that kills you is the one you smoked 25 or 30 years ago. So exactly, quitting. I'm not going to quit because I'm scared of tomorrow's cigarette is going to kill me, because that's not the one that kills you. So it doesn't, can't fix it. You really can't. Once you've been smoking more than 25 years, you will not change your ability to evade emphysema or lung cancer any amount. You just won't make any improvement in your odds. You're already cooked your odds. There's something nice. I want to thank you. Well, that's good. See, I'll just stop there when I'm winning. Anyway, you make me realize that kinetic energy formula was wrong. It's just a math thing. They made the integrate of MV. Yeah, well, I'm just saying that Leibniz was even cruder. It was just this idea that he believed in solitons and monads. He believed that God was intensely interested in planet Earth, it was a perfect world and some other kind of horseshit. Frankly, I don't know exactly why. I mean, obviously you can be fooled by impressions. Yes, if I showed somebody, just an honest person, a bullet, traveling through a gel, and then I showed a recoiling gun traveling through the gel, the bullet's going to look more impressive. And obviously if I hit somebody with a recoiling gun and I hit them with a bullet, it's going to look very different, right? The blood's flying out of the bullet one, all kinds of stuff is happening, and the person dies. And the gun, nothing. Right? Barely a bruise. So it looks really different. But a scientist knows, well, how it looks doesn't matter, because yes, the bullet's moving a tiny amount of matter at a high velocity, and the recoiling gun is going to vibrate or create pressure on a huge amount of matter. So the gun and the bullet are actually going to move the same amount of pins. They're going to knock down the same number of pins. So if I was using a bullet and I was using a recoiling gun to knock down pins, I would only be able to transfer their momentums. So the bullet and the gun would knock down the same number of pins. So that experiment would show the truth. But they never show that experiment. They always show the bullshit experiment. The one that deceives. The bullet, obviously breaks surfaces because it applies all of its energy in a tiny amount of time, where the recoiling gun applies the energy over a gigantic amount of time by comparison. And giving a surface time to react obviously gives a surface time not to be broken. I mean, you can use that example for water tension, all kinds of things. You can break water tension by moving something quickly. You gently put something on the water tension isn't broken. But if you put it on the water quickly, it's broken, and you're out of luck. You sink. The cult of physics. Physics is dumber than religion. Yeah, well, in some respects, it's more dishonest than religion, right? Because they can prove this. It's, religion you can believe in God and say, but I can't prove it because he lives inside my heart. Some kind of bullshit, right? But physics, they can actually prove this stuff, and they don't bother. I mean, they have zero experimental evidence demonstrating 25 times the fuel to go 5 times as fast. Nothing. And every single experiment you do that's anything like that proves the otherwise. Okay, every case proves that no, it doesn't take 9 times the energy to go 3 times as fast. So my example of being in space and I have 3 arms, right? So in one case I throw 1 ball, I go 1v. I throw 2 balls, I go 2v. I throw 3 balls, I go 3v. Their formula explicitly says I had to do 9 times the energy to go 3v. To go 3 times the velocity, I had to do 9 times the work. I had to supply 9 times the energy to have 9 times the energy. And I didn't do 9 times. I didn't have 9 arms. I didn't throw 9 balls. I mean, it just obviously doesn't work. And so you're saying, well, yeah, but so if religion said something like, well, it does say some dumb things, like the sun stood still, and obviously it can't happen, so there are provably wrong things in the Bible, and it's missing all the important part about like explaining the existence of microbes and the cause of disease, and instead turns all that into demons. So that part can pretty much be proven too. Well, let's just say it's just like a religion. We don't have to say it's worse or better. But it's no different. It's just as bad as. It's belief based on faith, not based on reason, logic, and evidence. Clearly, physicists believe stuff for no good reason. So that's just like religion. There's no good reason to believe in God. And there's lots of good reason not to. Yeah. So they're really doing the pseudoscience, and that's the real point. So that's the hypocrisy of Dave, is that he's claiming other people are doing pseudoscience and fake science and phony science, and that's all he's doing. That's all he's promoting. His science is just as incredible as flat Earth. The statements they're making, assertions about our reality, are just as incredibly wrong as flat Earth theories. Oh, you're going to bring up Adam Lanza? Yeah, fuck you in the ass until extremely dead. So just get what you deserve in life, you piece of ragged shit. I didn't know him. I didn't have anything to do with him. He's nothing to do with me or anything I've ever advocated. Go fuck yourself till you are good and fucking dead. People really are just so insanely petty. Ugh. They resent that I'm not ugly like they are. And so they have to attack me because I'm not ugly like they are. Yeah, it's that stupid. You have to be ugly to be respected. By the ugly people. Yeah. But if I was a chick, it'd be exactly the opposite, right? If I was a chick, I'd get everything I want and get all kinds of respect and admiration because I'm cute. Yeah. So, it's just funny how the world works. Let's see, the only way to skirt the... Oh, I don't want to do this theological argument crap. Is to deposit a multiverse. Just go fuck yourself. people are just so stupid. So robot guy, I guess I'll just, throw you in a timeout if you can't say anything reasonable. What's... LOL, what a sick person. The guy who wrote that comment username was... Yeah, whatever. Anyway, how can you be so fucking sick and twisted? Well, bringing it up doesn't help any, but fine. I am just saying that obviously that's... When people don't have an argument, they can't argue your argument. All they can do is argue lies and distortions and perversion. So that's all they have is, let's see if we can just make up some crap and try to smear it on him. Crap, let's smear crap on him. So, but that just demonstrates that they can't make an actual argument. So, I sort of win when people behave that way because obviously they can't argue what I'm actually arguing, and instead have to argue me, or attack me. The messenger is somehow the message. So they can't deal with the message, so they have to instead try to diminish the messenger. And obviously I'm not a cult figure. I'm not expecting to gain any interest by being seductive. I love you. Please, please love me. No, I'm not going to be doing that. Hey, YouTubers. Oh, you guys are so special. No, you're not going to see that on this channel. So let's see. I hate when we to whatever this is. Consider theory because when we start, I guess that might mean because a math theorem confirms it is right, so it means that it is real. So again, I doubt this idea that a math theory was confirmed. I'm simply arguing that obviously I don't think Schrodinger's equation's ever been confirmed because it has elements in it that are completely unattainable. I mean, it has variables you can never put in the equation. So obviously you can never solve the equation because you can never put the variables in the equation. So I'm saying, what's the point of arguing an equation that doesn't work? It doesn't produce an answer. This is the reason we have those wrong physics formulas, because they were not experiment. Well, clearly, yes, it's true that they're not proven because the experiments don't actually do what they claim. I mean, the experiments don't do what they claim, and the formula doesn't represent the right variables in the experiment. So again, when they say the double slit has two waves, the math they're using doesn't have the centers where the wave centers would be. That is, the center of the slits. The math that works identifies the surfaces as the distance you measure from. That's where the vectors are coming from, the surfaces. They're not coming from the center of the openings. And it's only when you have exactly the same size impediment as you have size opening that you could use the distance of the center of the waves and get the right answer. Otherwise, you won't get the right answer. So the formula only works in one special case. So that's the fraud of it. They say, let's have infinitesimally small slits. Well, what does that do? Well, that basically just says you're back to a double slit. You're back to a single slit experiment because you've destroyed two of the point sources. So you only have 2 point sources again. You only have 2 surfaces, essentially, because 2 of the surfaces are so close together you can't draw a vector from them that's different. I mean, it's just cheating. So they have a formula that only works in one circumstance. Kinetic energy only works in the one circumstance where you make up your fake energy going in and you hit an object that's exactly the same mass, so you have exactly the same fake energy going out. But that's the only time it works. It doesn't work any other case. You can't conserve it in any other case except transfers between equal masses. In any transfer between unequal masses, you're out of luck. you have convinced kinetic energy is a lie. Okay, me. All right, got it. Good. I mean, but frankly, everybody should already be convinced. I'm just saying, right on its face, it says 25 times the fuel to go 5 times as fast. Everybody who's driven a car or pumped the pedals on a bicycle or done anything knows it doesn't take 25 times the energy to go 5 times faster. It's just silly. How can they say something that dumb? And it's just amazing that I have to spend years arguing this to slowly but surely convince a few people to doubt. You know, as soon as somebody says that to you, you should be doubting. I mean, 9 times the energy to go 3 times as fast. I mean, all of them, 4 times, 16 times the energy to go 4 times as fast. It doesn't make any sense. Yeah, my first philosophy book was Dr. Seuss. Yes, frankly, I never grew out of it. Star Belly Sneetches and Horton Hears a Who. It was good stuff. I wasn't a fan of green eggs and ham, though. I just kept going over it and saying, what the fuck is he talking about? What the fuck is he, And I guess it's something to do by trying something new or something, that you should try stuff. And I was like, yeah, but what if the ham, you're allergic to it and you die? What's the point of trying the stupid ham? Who cares about the fucking ham? Do I really give a fuck about eating ham and eggs? No, I don't even like eggs, so fuck you. I don't want to, don't bother me with this nonsense. I'll go have a bag of potato chips. So yeah, that was a real clunker. Cat in the Hat was magnificent, in the sense of, just demonstrated exactly my point that life is way too messy and there's no magic. You don't get to just open your hat and a bunch of guys come out and they clean up all the mess. That don't happen. So another bad metaphor in the sense that, oh yeah, I wish life was so easily, that mistakes could be so easily fixed. So I was always paranoid. I spent my whole life being paranoid because I'm basically just saying, well, life is going to do something stupid. I'll say hello to somebody, they'll slip on a banana peel and break their back, and then it'll be my fault. I mean, it's like, I was already just, everything you do is too risky. It must feel like shit to explain something that's so obvious. Yeah, it feels like shit that I did all this work. I spent 10 years immersing myself in this physics. And I actually did something insanely constructive in the sense that I found really simple answers to these complex subjects. Insanely simple answers. And my reward is belligerent retardation. I mean, I don't get anything for my trouble because no one will listen to it. So, building it, I did all that work to make this magnificent statue, so to speak, and nobody will look at it. And it's like, oh, fuck. What's the point then? Okay, let me see what this all says. At Shield, to present your argument, so far I haven't seen any that actually proves him wrong. Much of Effelism you can't... Well, we're not doing that subject. This is a physics video. No issue. Let me into a call and I'll share my screen providing everything. What the fuck is that nonsense? But that won't happen, of course, because he knows he's wrong. Send me an email, you piece of human garbage, okay? And I can't open this room to somebody else, okay? That I can't do. but I can make a room if you're willing to be in it. And that's fine. But you have to show your stupid, cruddy little face, and you have to be able to have audio, and frankly, it would be good if you could actually draw something. But you won't do any of this. So I'm just going to time you out because you're just talking shit. Yeah. Okay. So why can't you make a video? So why don't you tell me, Mr. Shield? Okay, I can't go to your channel right now, but you have a channel, right? Why don't you make a video? You have a channel, you can make a video. So why don't you just make your response video? So I did gravity, I did kinetic energy, I did the rolling ball example. Why don't you just show me where any of that was wrong? Just show me. Show me where something in this drawing was incorrect. Make a video. And then we can have a live conversation. So once we know you're credible and that you can actually make an argument, then we'll waste time on you. But until then, what are you talking about? You can't even make a video and you want to be in a live room? Sure, no issue. Whole playlist. I just want you to make a video. Can you make one fucking video debunking one of my arguments? Just pick one. I mean, what's the resistance to you making the counter argument right now? Provide me a link right now. So email me a link to any video you have made debunking anything I have said. Email address is right below, ds@donotgo.com. Not hard to do at all. Just post an email with a legitimate link to your channel and a video on your channel that debunks anything I've said in these videos. Alright. Physicists are weird. I prefer experimental, whatever that is, physician. Maybe that's why we never agree on something. It's not theoretical when I produce a simulation demonstrating it working. So again, you want to argue it's not a real model. Of course it's a real model and it really comes up with a result. So eventually I'll have a simulation of gravity and then I'll have a simulation of drag. But right now I have a simulation of charge that works perfectly, creates everything Maxwell talked about. That's not theory anymore. Because I need to write things. And YouTube comments don't work. Well, anyway, I'm not going to play with you, okay? You need to write things, but you want to do a live conversation. That's not going to happen, asshole. So make a video, prove you can make a video, then I'll have a conversation with you. But until then, fuck you. You're just full of shit. So you're going to be timed out because you're wasting my time right now. You've been invited to provide some kind of credential, and it's a minor credential. Make a video. Hit the make video thing on your screen and make a video explaining what you're talking about. Present me your argument that you would make in a live room. I mean, obviously I have great deal of, I love experiments. So yeah, the more experiments, the better. But what experiments are they doing? They're blowing up watermelons. They have high-speed cameras and they're wasting them. Blow up an egg, blow up a tomato, blow up a watermelon. They're not doing any experiments with the high-speed camera that matter. They should be doing the Newton's cradle. They should be doing lots of things, and so we could actually see the mechanics. And instead, they're wasting it on nonsense. And then the simple truth is that some experimental physics is bullshit, right? I mean, do you understand, okay, that the Chardonnay experiment was shyster? Denting clay, just denting the surface, barely denting the surface with objects, round objects. That if you just dent the surface with a round object that's not any different than, using a pointy arrow and dropping a non-pointed arrow and then measuring which one goes in deeper. I mean, duh, you know which one's going in deeper. So I'm just saying, do you understand that some experiments are deceptive because the variables haven't been accounted for? So all the spring experiments you see, right? I mean, I pointed out how springs work, that springs give more of their energy the heavier the object they're pushing. So the heavier the objects are getting pushed, the more of the spring's energy gets all used. And the lighter the object being pushed, the less of the spring's energy gets into the object, because the spring oscillates more. So you can just imagine it for yourself, that yes, if I put a piece of dust on a spring, the spring's going to do this. All the energy is going to be stuck in the spring. It's not going to go into the dust. But if I put a real heavy object, as soon as the object leaves the spring's going to be going very slowly, and it's barely going to oscillate. So all of the energy got out of the spring. Most all of it. I mean, those are facts, right? So the experiment is deceptive if you're assuming the spring is fair and it treats light objects the same way it treats heavy objects. It doesn't. Funny, you put somebody in a timeout and they delete the comment? Weird. Yeah, that's strange. I mean the previous comments, but whatever. But I mean, that's the perfect way to talk, in my opinion. I mean, I would prefer to exchange videos with Professor Dave than to actually have a live conversation. Because live conversations end up getting distracted and distorted. You end up talking about some little minutia thing rather than the actual subject. Where if you just do video exchanges, you can, you can keep reshaping and refocusing the subject. You don't have to get distracted. You can pick out the key parts that you disagree with. And you also have so much more time to think about what you're going to argue. You can play the video and realize, okay, well, that's sort of a good point, that's a bad point, blah, blah, blah. You can't do that in a live conversation, right? Because you have to do all that thinking ahead of time. You have to see all the tricks he played in the video while you're doing it. And it's so much easier to see the tricks, in hindsight. So video exchanges are fantastic. And it's just terribly tragic that nobody does them anymore. I still do, but the rest of the internet doesn't. Yeah, it's just, like I said, I'm doing the same thing I was doing 20 years ago on YouTube. Nothing's changed. And it's the rest of YouTube that has changed. The rest of the players have decided not to play that game anymore. And that was the best game we had. I mean, video responses are just fantastic. And the big joke is not only they got rid of the actual thing called the video response, but now when I post a link to my videos on somebody else's channel, they delete it. They're afraid to even let my little link sit there. I made a response video and I post the link. That to them is a threat. I mean, just leaving that one little comment saying, look, I made the video, okay? It's about your video. It's not spam. It's not fake. It's a response to what you said. Why should you block that? I didn't lie about you. I didn't, associate you with the Unabomber. I didn't do anything, all I did was say I disagree with you and what you're saying is wrong. And they won't let me do that. Well, that's the joke. I mean, the internet loves blood sport. Well, aren't video responses blood sport? It doesn't love that. It loves troll sport. It loves unaccountable people throwing spitballs. It doesn't love fair fights. And I think people would love fair fights. And all they're given is troll fights. who can troll somebody else, who can Photoshop. That's all they're given. Well, Gilbert, I don't know. You're way out there comparing chimpanzees to Nazis. Oh, jeez. I mean, obviously, the Germans had an emotional problem, okay, and decided to just take a huge shortcut and pretend that somehow, it was the Jew horns that were the problem in the world. And that was just too ridiculous. But I don't know if I'd bother comparing it to chimpanzees. I mean, you can compare every emotional problem humans have to a chimpanzee, I guess. But, don't know if there's any point in that. Let's see, I don't think that the scientific community should emphasize empirical methods rather than just accepting theories. It's just an argument, and the fact is you have to have the argument. The fact is they haven't done anything to defend their position. Again, they haven't measured 1 pound dropped 4 feet, 4 pounds dropped 1 foot. They haven't measured that weight. I think that scientific community doesn't respect scientific method anymore. Well, they never did. That's sort of the argument. When did they? They never repeated the Eddington experiment. I mean, I could go all down the list of all the times they violated any notion of doing the experiment multiple times in multiple ways to make sure your results are coherent. Look what they did to the double slit. Again, infinitesimally small slits. Why would you choose infinitesimally small slits? Why don't you just open the slits and see what kind of pattern you get? So it's ridiculous. There's no scientific method in the sense that they're designing experiments to confirm what they believe. They're not doing the other way around. They're not letting the experiments tell them what the truth is. They're forcing the experiments to match their truth. Well, yeah, but I mean in its rawest form, so I guess I could say troll sport. Okay. You see YouTube like Destiny. This is the Joker. I mean, obviously a gigantic percentage of people are just going to watch anime or something. Okay, you can't do anything about those people. People watching Destiny or Varnish or whatever the hell you're saying. These are people who are not. They're not doing anything reasonable. They're doing Vogue stuff and style stuff. It doesn't have anything to do with life. Oh, let's not get into race realism or any other kind of nonsense, please. Oh, Jesus. See, this is part of the problem, frankly. I mean, I'm doing a physics video, and, you people are really going on all kinds of sidetracks. All right, so maybe we're done. So yes, it's kind of tragic that each night the number of concurrent viewers keeps going down. So we're under 10, not good. But at least the 10 people, at least there's a third of them talking. So that's. It's enough, I guess, for, it barely keeping this video alive. Yeah, so if we had like 3 other people talking, then maybe the video could just keep going and going and going. But, it just runs out of steam here. Not enough viewer pressure. Not enough statements like, well, could you re-explain that thing about the thing that you said the thing about? I could say, yes, I can do that, but, Yeah, I don't get any of those requests. So, I'll give you a moment to see if you have anything to request in terms of a drawing. And, try to keep it clean and such. Yeah, fans. Just a horrible concept, fans. Love the truth. Ignore messengers. I am substantially irrelevant. I am just a machine, a robot, and the robot recognized that it's living in a bullshitiverse, and it said, I don't really like living in a bullshitiverse, so I'll go find the truthiverse, and then I'll tell people, hey, I'll wait over here to the truthiverse, and this is what it looks like. And I'll try to explain to the people in the bullshitiverse that you really don't want to be in a bullshitiverse, do you? Do you really want to just waste your whole existence in a bullshitiverse, doing bullshitty things for bullshitty reasons, when you could go over here? Just move a little bit over this way, and you'll be in the truthiverse. And so that's all I'm doing. I'm just a guide trying to get people to just move their perspective a little tiny bit, and they'll see the truthiverse. Yeah. Well, that's my analogy for today. If we would apply true scientific method, the truth, empiricism, mathematics should be considered as scientists. Shouldn't be considered as scientists. If we would apply true scientific methods, the truth, empiricism. Why are we bothering with empiricism? I mean, why are we bothering with something other than just stating it should be reasonable? Like a reasonable doubt kind of standard. We're just trying to prove a case. And you say, well, this is kind of, anything above this amount is proof. And you can have like insanely proven, or pretty proven, or substantially proven. You know, you can have degrees of proven. But you're just saying, here's the standard, okay? This is where you've really established that, like the law of the lever. You spend thousands of years using scales and it works. Yeah, it's pretty much substantially proven that the law works and that it's reasonable and sensible. And there's no real sensible challenge to the simple fact that, yeah, you're weighing things. You're comparing their weight. All right, anyway. Mathematicians. So, I mean, you know, there's nothing wrong with math that isn't contrived. I'm just saying all the math is contrived. Okay, it's not derived. Yeah, that's probably a good way to say it. Right? Saying per second, when you know it's 1 second, and you know you can't square a 1. So what's the point? What's the point of 9.8 meters per second per second? Why would, or second squared? Why would you say that when it's 9.8 meters per 1 unit of time, 1 second? I mean, those are the kind of mathematical distortions that you're saying. That's not a derivative. That's a perversion. You know, people are not truth-seeking machines. Well, I think they are, but they're lazy and they're selfish. So, yes, if the truth doesn't match what they need it to be, I'm not fat, I'm just, big boned, then they, make up some fake theory that big bones make people fat. So they will never try to find the truth. 99% of people are just, driftless. I don't know what that means. Clouds that live on the instinct. Well, I just don't agree. I think this is way hyperbolic. You're exaggerating too much. People are ignorant. it's really hard. Physics isn't easy. You have to really acquire a lot of knowledge, and people are just too lazy to do that. And too distracted, frankly. I mean, they got to make a living. They got to do all kinds of other stuff. They got to get, laid. They got to do all kinds of projects besides knowing how the real world works. That's not going to get them, enough money to buy some cigarettes. You know what I'm saying? I'm not making excuses for people being as dumb as they are, and the fact that they think they're smart when they're dumb, the whole Dunning-Kruger thing or whatever. I mean, the fact that these stupid people think they know something, that's the part that's just, why would you think you know something when you know you don't know shit? I mean, that's the funny part almost. Maybe, but it's limited heuristics. By heuristics, you're just full of jargony. You ought to just change your name to Gilbert Jargoni. It's just jargon. Sorry, it just reads like jargon to me. These, sorry. Just, again, the statements aren't direct enough and clear enough. And again, I'm not trying to talk to the public. I am trying to deliberately, excessively trying hard to talk to physicists. I mean, that's all I do try to contact. That's the only people I do try to interact with are people who do already know the subject. They went to the school. They watched the Professor Lewin videos. I mean, so we can discuss the subject because they have the same knowledge base that I have. But the fact is that even the physicists don't know who Leibniz was, and they don't know what de Chardin was, and they don't really know the history of mv squared. They don't really even understand that Joule did specific experiments, and that his experiments were flawed in the sense that he pretended to think no matter how fast a weight drops, it collects the same gravitational energy. So even if it drops really, really slowly, it's collecting the same energy as if it drops really fast. And obviously that doesn't happen. The longer you're in the stream, the more energy the stream will impose upon you. All right, I said this because a pure mathematician and a applied mathematician are, I don't even want to do this. This is just cutting all kinds of stupid, weird hairs. Are different. The first one based on the ideas on axioms, and sometime they are not in reality, whereas the other ones work with reality. Well, I suppose you say so. I have to take your word for it. Because, there's not applied math, there's applied science, I guess you could argue. And there's shortcuts that get you right answers, but they're wrong in premise. So obviously in gravity you can do you can measure the distance and know, well, it's the square root of the distance. It's the amount of force, so I mean you can fix what they broke, but it only works again in these tiny narrow circumstances. So what's the point of saying MGH when it doesn't work if the object is already moving and it goes into gravity? It only works if you artificially place something at a certain distance from a stopping point. And that's the only place it works. And it doesn't work in the sense that if you measure the distance and not realize that it's the time that matters, you're not going to get the right answer anyway. Anyway, I'd like to understand physics and help argue, but I'm going to be checking out soon, so thanks. Not much help, unfortunately. Well, sorry about the having to check out. We're all time limited, so eventually I will have to check out, and it's awkward. It's awkward. I wish you could hang around and help, but if you gotta go, you gotta go. So, I hope you have to go. I mean, I hope you're not just being lazy. You're selfish. Sorry about that one, but why bring it up here? I don't know what that means. Sorry about that one, but why bring it up here? I don't know what that means, but okay. Whatever. Yeah, I don't know. Yeah, sorry. Can't follow. Speaking. Why bring it up here? Well, he's just letting us know that's not a bad thing to do. I mean, he's saying, look, I'd like to help, but yeah, unfortunately, I can't help because I'm not going to be here, so I can't help. Nothing wrong with saying that, I suppose. I mean, it seems reasonable if you're leaving to say I'm going, and, you know, nice knowing you. Yeah. I suppose you could just send an email and say it, but whatever. I don't see a problem. I mean, unfortunately, this is something I run into a lot because of the other channel. So, you know, it's just, there's a lot of people who are, you know, have a very difficult existence that end up watching my videos. And so, you know, it's a real circumstance, you know, that they're often participating while in pain, and you know, it's difficult to interact when you're not feeling well. I should know. Ugh. Anyway, ouch. God, sucks getting old. That's how I found your videos. Yes, that's the unfortunate part. Is it's hard to find my videos. So that's, you know, makes the game really hard to play. So the only way the game can be played is these, you know, you have to get lucky enough. And the fact is you have to network. And, you know, obviously I can't network with people I completely disagree with, right? How can you network with your enemies, so to speak? So that's a real liability of being a dissident, is there's nobody to network with. I mean, I could network with flat earthers, but I obviously hate flat earthers, so I can't really network with flat earthers. I mean, there's no peer-reviewed dissident community. So what the dissident community needs is some way to separate the complete whack jobs from people who have some hope of making a cogent and relevant argument. You know, and that's the problem. And it just seems like, you know, frankly, if there's 1,000 people, 1,000 dissidents, they're all wrong, except for me. You know, that's the way it turns out, right? You know, they're always wrong. I mean, I can't find anybody who's a dissident who's actually making a good argument. It's just so rare. I mean, Miles Mathis is out there, you know, constantly jabbering about how he's right and they're wrong. So his arguments about them being wrong are often correct, but his arguments about what he says is right is just as silly and stupid as the thing he's complaining about. So he's not advancing the ball any. And the rational science guy does the same thing. Bill Gates is doing the same thing. He's right about a lot of his arguments about how they're wrong, but he's completely a lunatic in terms of the replacement theory is rope theory. I mean, it's just so fucking stupid. Let's see, I'm emotional about it, but I'm not emotional when speaking about it. I like to be rational. Okay, that seems a reasonable enough statement. I suppose. I mean, you can't be unemotional, frankly. I don't know what you can, I mean, everything triggers some sense of comfort or apprehension. It's like every word is loaded with some triggers, so it's hard to not constantly be tugged by visceral smells, like words smell. Like somebody types something and it smells good or it smells bad, kind of thing. And it's just you can't help but smell what they're writing. I guess that's the analogy I would use. And obviously sometimes the smell is deceptive, and it's a perfectly good blueberry pie, even though it smells like a dead rabbit. All right, I guess it's time to go. Anyway, yeah, see, I get a little tired, of, constantly making physics arguments. You have to really think about what you're saying. You have to make sure you don't say proton instead of electron. You just say photon instead of electron. You do some other stupid thing, or you say something backwards and blah, blah, blah. And so that part is irritating because you have to be, obviously when you're drawing something especially too, you have to keep it all coherent. And so it's a kind of work, and so I get fatigued by doing the work, and so I want some kind of interaction that's a little simpler, and but unfortunately this interaction is just not on the physics subject enough to be worth continuing. So I probably shouldn't bother continuing it. Yeah, that's what I'll say. Probably not. We probably should just say yes, okay, we'll call it a video and such. So anyway, appreciate the participation, and we'll keep poking at this and see if we can poke our way into getting a response from some physicist someday. I can only hope and try, and that's all I can do is try and fail, which is, as Yoda would say, there's do and do not do. Try is bullshit. There is no try. Trying is useless if it doesn't work. Yeah, it's just a fact. But it's all you got. So you have to go with it because there's nothing else to bet on except guaranteeing failure. So if I don't want to guarantee failure, I have to do the try thing. Alright, so hey, that's good enough reasoning. And so I'll just keep trying. And such. So, till the next time, and such, and so forth, and the whatnot. I'm going to just find the right window here. Should be this one. But it's not. Yeah, thank you, YouTube. No, it's not YouTube's fault. Alright, so, I will say goodnight. So, till the next time, blah, 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 blah. End.